Hi, it's Neha again, and welcome back to NeetCode Easy. Today we are solving problem 8, valid Sudoku. If you don't know what a Sudoku is, let me explain you quickly. Sudoku is a number puzzle played on a 9x9 grid. It looks something like this. And as you can see, we have 81 squares in total in this grid, and this large grid is further divided into 9 smaller 3x3 boxes. So this is one box, this is the other one. In total, we have 9 boxes. The interesting part is, while the digits used are always from 1 to 9, the way they are arranged will be unique in every row and every column. That means no row can have same number twice, no column can have same digit, and each 3x3 box must also contain all digits from 1 to 9 without any duplicates. So even though the set of numbers stays the same, the combination and arrangement of those numbers is what makes each Sudoku puzzle different and challenging. Now this problem doesn't ask us to solve the Sudoku. It just asks us to check if the current board is valid so far, meaning it follows the Sudoku rules. So the statement here is, you are given a 9x9 Sudoku board. A Sudoku board is valid if the following rules are followed. Each row must contain the digits 1 to 9 without duplicates. Each column must contain the digits 1 to 9 without duplicates. And each of the 9 3x3 subboxes of the grid must contain the digits 1 to 9 without duplicates. Let's talk about the input and constraints. So here we are given a 9x9 board. Each cell either contains a number like this or a dot here. A dot simply means the cell is empty. Moving on to the constraints, the board will always be 9 rows with 9 cells in each row. Each cell will have either a number or a dot, nothing else. And again, we are not required to solve the board, only to check if the given board is valid. This makes the problem very manageable and efficient to solve. So the idea here is simple. First, we check each row. If it has duplicates, we return false. Second, we check the two columns. If it has duplicates, we again return false. If the rows and columns do not have duplicates, we then check 9 subboxes. If any of them has duplicates, we return false. And once the 3 conditions are met, the given Sudoku board is valid and we return true. To solve this problem, here is what we will do. We will initiate 3 if statement to check if each row has 1 to 9 digits without repeat. We'll do the same for columns and for the boxes as well. If 3 conditions met, we then return true. So let's start writing code. First, we initialize a list of 9 sets, one set for each row to track the digits seen in that row. So for that, I'll use a list and initiate 9 sets. So for I in range 9, so this line will create 9 sets inside this list, and I'll save it into a variable named rows. And then we do the same for columns. So columns equals set for I in range 9. For 3x3 boxes, we use a default dict. So default dict of sets to store digits seen in each of the 9 boxes. So here boxes will be default dict of sets. Now we loop through each row and columns. So for that, we are gonna need 2 loops. For I in range 9, then for j in range 9. And now what we do here is, we check if the current cell is empty, which means it has a dot. We skip it and we keep looking, we keep scanning until we find a digit. So if board ij equals dot, if so, continue. And once we find our first digit, we check if the current digit already exists in current row set. So for that, I'm gonna use another if statement here. In the rows I. If so, we return false. Otherwise, we add it to the rows here. So rows I dot add. We'll do the same for columns as well. In columns j, return false. If it's not there, we simply add it. And lastly, for boxes, before we check our boxes, we need to determine which 3x3 box the cell belongs to. So for that, we are going to use integer division. And then we'll use a tuple, not a list, because list is unhashable. So we are going to use tuple here. So here, I'll name it box keys. And this will be a tuple. So we first divide row by 3 and then columns by 3 and get the integer value. Now we check if box ij in box keys return false, otherwise add it to the boxes. So boxes box keys dot add, simply this. And once we check everything, once we see that everything matches, like all the conditions are met, we simply return true. Now we have the code ready. Let's run this and check if the test cases pass. Great. All of them are passed. As you can see here, we have a solution. So here we have used 2 for loops and 4 if statements. But if we look closer, we are using 3 if statements here. And all of them are checking the same thing. Like all of them are checking both ij in rows, columns, and boxes. So we can convert it into one statement. So here, what I'm going to do here is, so simply cut this and here put or, and then this one. Let me do a little bit cleanup here. So here we need to remove this and again this, and this line will be at the top because before using it in here, we'll have to declare it at the top. Now this looks cleaner and you can see it's manageable. Let's run this. Let's run this again and check if we still get the same result. Now as you can see, It's working completely fine, and we have got the solution here. So here we are checking every row, every column, and every board for a digit. Once we get a digit, we check for duplicates. Once we check, we return false if it exists, if duplicate exists. Otherwise, we add it to the corresponding row, column, or box. Let's check the efficiency here. So here we need to aim for big O of n square or better for time and space. But even though we use two loops here, one for rows and one for columns, the board size is always fixed at 9 by 9. So in total, we are just checking 81 cells. That's a small constant number. And in big O terms, we drop constants, so we call it big O of 1 or constant time. The same goes for space. Our row, column, and box trackers are always the same size. So the overall efficiency is constant both in time and space. So our solution fits big O of 1, constant time. And that's our problem 8 solved. Our next problem is longest consecutive sequence. If you are enjoying the series, stay tuned and I'll see you in the next one. Bye bye.